Hi, my name is Joaquin, and I'm here again to teach you to learn about Venn diagrams. So, what are Venn diagrams? Venn diagrams are a graphical representation of questions on sets. Okay? So, for example, we have questions, logical questions or problems. We will be representing them through circles. Okay, then that's usually what Venn diagrams are, basically. So we have like a truth table. Venn diagrams have the same like operations. Like remember the disjunction, conjunction, negation, exclusive, or biconditional. Some of those can be applied on the Venn diagram, like the negation, conjunction, disjunction. Sometimes exclusive also. So let's start with an A naught or A negation. So for example, we have a circle here that could be represented by A. Okay? Then we have a B here. Okay, usually Venn diagrams are drawn like this because we would see the commonality between the two. Also, you're trying to find out the number based on the word problem. Later on we will tackle about that. So let's say A is this circle, right? And B is this circle. So if you want to go A naught, make sure you pick or shade the circle that is not part of A. So you see the circle here is part of A, right? So we will be shading the one that's not part of A. Okay, make sure you don't shade this because that is, yes, it is part of B, but it is also part of A. It's the intersection between the two circles. So make sure you don't shade it out. So Venn diagrams like this is like a graphical representation, right? So this is like that. So let's say A conjunction B, right? So remember conjunction? It's like always positive, right? So what do you say? So by the way, this square here or rectangle is the universe of the question or the like variables that's the world it's in. So we actually usually do that, represent these things here. So we have A, B again, and it's the positive guy, right? The conjunction. So it should be positive since it's actually shading both. Since union or rather conjunction is, if it's both one, it will be already true. So this is like a union. So for example, we have set A and B. Union means you have to join all the elements of A and B. Okay, so we have to shade everything. Now the other one, disjunction, we have A disjunction B. So in this case it should be something like a negative guy, right? But here we have an intersection rather. So we have circle, sorry about that, another circle, A, B, and let's draw the universe here. So we would actually have the one in the middle, since that's the intersection between the two. Okay, that's where they cross paths. Like in the set A and B, for example, we have A set as 1, 2, right? And B as a set of 1, 4 element. Then the only intersection that they have is this 1, 1, right? It's the only commonality they have. So it's basically like this. Commonality that it has is in the middle. Okay? So also, by the way, sometimes if you say A naught, since the universe is also involved, you can shade also the universe since it's not A also. Okay? So, next one, we have the, yeah, that's usually it, what we use. We don't usually use the others unless it's, I think it's, if it's more advanced. But we also have disjoint sets, wherein they don't really have anything in common. A and B, these are disjointed sets, that's what you call it. So that can be applied to, for example, we have A here, right? 1, 2, it has elements 1, 2, B has elements 3, 4. So what do you call this? Since they have nothing in common, that is called a disjoint set, okay? Okay, so let's now go to Venn diagrams in word problems, which is usually used on. So let's say Ben has 4 apples, and Gwen has 9. What's an apple? Mangoes, rather. Okay, Ben has 4 apples and Gwen has 9 mangoes. Okay, so you can label this as, oh, I'm sorry, quite hard to draw. Okay, you have Ben here, label it, make sure, and Gwen here. So Ben has 4 apples, so you can put here as 4. Gwen has 9 mangoes. Okay, and like you can add, so for the intersection they have both apples and mangoes, they can have around 2. Okay, you can put the 2 there. Alright, so that's usually how Venn diagrams work. Okay, there are much more complex problems, but this is the basic, so this is what we have here. Okay, you can learn more, just focus on the basics first, then it'll be much easier for you.